matter what kind of research you do or where you are in your career, sooner or later you will come across the FAIR principles for research data. Applying the FAIR principles means to make your research data findable, accessible, interoperable, and reusable. Findable means that others can discover your data. Accessible means that your data can be made available to others. Interoperable means that your data can be integrated with other data or can be easily used by machines. Reusable means that your data can be used for new research. These 4 principles should be applied throughout the entire data lifecycle, and they are closely interconnected. Please note, applying the FAIR principles to your research workflows does not necessarily mean that you share your data openly. FAIR data is not the same as open data. Open data is data that can be freely used, shared, and built on by anyone, anywhere, and for any purpose, while the FAIR principles provide a set of best practices for sharing data, respecting any ethical, legal, or contractual restrictions. If your data contains personal information or is subject to copyrights or intellectual property rights, you must comply with regulations and protect your data from unauthorized access. But even if the data itself cannot be shared openly, you should create and publish a description of your data, so that researchers with a relevant purpose can request permission to reuse the data. This module introduces you to best practices for making your data fair. Following these best practices will help you to produce high-quality data that can result in maximizing your research output and impact and enhancing your recognition as a researcher.
We're producing more and more data all the time, and if we don't add structure to that data, we only make it useful for ourselves. So the FAIR principles provide a way to extend the reach of our data and to allow more people to make use of it.
Well, for me as a researcher, the FAIR principles are very important because I think it leads to better research. In archaeology, for example, which is a destructive discipline, we can never go back and reconstruct the point of departure. So it's alpha and omega that we actually make the data available to our colleagues, because we can't reproduce data sets in archaeology. We can only work with that one data set that came out of the ground in that one moment. And that's why I think we have a moral and work ethical obligation to share that data across archaeology.
The FAIR principles were drafted by an expert group consisting of researchers, funders, publishers, and university representatives in order to increase the reuse of scientific data. They explain their motivation for establishing the FAIR principles as follows. Researchers claim that FAIR data result in better research output. Funders expect FAIR data to add more value to publicly funded research. Publishers anticipate FAIR data to improve the peer review process. For universities, FAIR data are a means to ensure high research integrity. Since then, the FAIR principles have gained broad attention all over the world. Funding agencies are incorporating them as part of their guidelines, and research institutions are including them in their policies.
The FAIR principles are part of the open science policy at the University of Southern Denmark, and as such they guide our researchers on how they should manage research data. FAIR data contribute to the transparency and reproducibility of the research that our institution produces. More generally, the FAIR principles enable researchers to contribute to open science with high-quality research data.
How you apply the FAIR principles depends on your specific discipline and your ways of doing research. But there are several elements you must consider within your research workflows if you aim to make your data fair. For example, documentation which provides context and makes your data understandable for others. Metadata which makes your data easier to discover. Data formats which are important to consider when you want to combine data sets or make data readable by machines. Access to data, which means that you determine who you make your data available for and under which conditions. Persistent identifiers, which are long-lasting links to your data that enable others to find your data and refer to them. And data licenses, in which you determine how your data may be used by others. These elements and their importance to make data fair are explored in the rest of this module. Let's first look at documentation and take archaeology as an example.
We record all data that comes out of the ground when we excavate, so that literally means everything. Ceramics, glass, metal, structures, any empirical primary data that comes out of the ground. So it's important to register all that evidence together. And that's done on what we call a total registration sheet. In this context, there are a variety of objects which came out, and I think it's about 200 and something in total, and they're all registered on this sheet. And in a second step, very particular or representative pieces are then noted on their single sheet, and that's where an exact find number is given to the object so that we always can go back in our storages and find exactly that object to study once more if we would like to. Well, the benefit of full quantification is that you have an exact and complete overview of all the finds from the excavation, no matter whether you are only interested in ceramics or glass or metal or architecture. You know what the total is of what you have. And that's very important to have, because then you can actually also begin to share the data with other people working with other materials and in other areas of archaeology.
Here are a few tips on how to document your research data. At the very beginning of the project, agree with your colleagues and collaborators on a common strategy for structuring and documenting the data. Document all the details on how the data were collected or generated, for example on methods, instruments and software. Document the entire research process. For example, who has worked with the data? What has been done with the data? How are these data related to other datasets or publications? When you document the research process, you provide context to your data so they can be read and understood later on by other researchers and yourself. Another important type of documentation is metadata, which is data describing data. Think of the metadata of a photo. When you take a picture with your smartphone, information like location, date, time, file size, file format, and the technical specifications of the camera are automatically saved with the picture and embedded in the file. Other metadata are added manually. When you share the picture on social media, you can add names, tags and keywords, etc. Metadata are very relevant for both humans and machines to access, understand and process data. For example, algorithms recognize tags and relate your picture to other similar content. Researchers have always worked with metadata, and many disciplines have developed standards for data description. For example, within botany, genomics, and astronomy. Metadata standards intend to establish a common understanding of the meaning of the data to ensure correct and proper use and interpretation of the data. Metadata standards are also key in technological research such as wind energy.
My research is about the energy that's contained in the wind and how we can forecast that and estimate it through modeling. In particular, I focus on the impact of icing growth on wind turbine blades and how that decreases the amount of energy that we can get out of the turbines. I work with two main types of data. One type of data comes from the numerical weather prediction modeling that we use, and that's four-dimensional data. So it has time, height, and then latitude and longitude dimensions. And we look at that data in order to understand what's happening in the atmosphere. Then we combine that with the operational data of the turbine, which you can think of as like a spreadsheet of all of the sensors that records in time, all of these different sensors. And then what I do is combine those two data sets to understand how the atmospheric data affects the turbine behavior. So the main type of metadata that's important for us in our research is the spatial and temporal dimensions of our data. So when we try to combine this operational data with our model data, we have to know that we're in the right place in space and the right space in time in order to make sure that we have a good relationship between those two. So those are really key features of metadata. And then of course things like variable names and column names to make sure that we understand what's hidden behind that metadata and having as much description as we can of that data, including units, so that we know that we're comparing apples and apples. The thing that standard metadata gives to us that ad hoc metadata doesn't is consistency and the ability to do machine processing. Most of the time when you're doing data combinations, you spend most of your time preparing the data to make sure that you understand it. When we have common metadata, we have less time that we spend preparing the data and more time that we can actually focus on the science, because we know that wind speed as it is out of the model is the same as wind speed that's out of the turbine, for example.
Good metadata will ensure that your data are easily findable, interoperable, and reusable across systems, disciplines, and languages. One example of a metadata standard is Dublin Core, which is used in many disciplines and includes general metadata fields like title, creator, and subject. Another example is the Data Documentation Initiative, which is mainly used within social, behavioral, and economic sciences and includes more specific metadata fields like subject terms, geographic coverage, and time period. Whenever possible, use metadata standards that are established within your research discipline, established according to best practices, or commonly accepted and used. If there is no common standard in your discipline and metadata is not generated automatically, add all relevant metadata that you believe are needed to understand your data. For example, prepare a README file with metadata describing your dataset, keeping in mind what information is needed for others to understand it. When you properly document your data and add relevant metadata to it, you are one step closer to making your data fair. Using open or standard data formats will also help you advance a step towards fair data. Let's hear why.
Open data formats are really useful when you get data from other researchers and when you're trying to share your data. Sometimes you'll get data that's in kind of a strange binary format, and then you have to write your own code or you have to compile someone else's code in order to actually work with that data. But when we use standard file formats, then there's a robust library package that you can usually pull in almost any programming language, and then that actually makes it so that that data is truly interoperable and that you can just grab it and use it rather than have to talk with someone and have a lot of communication, which slows down the whole research process.
In the field of archaeology, common data formats are not entirely established yet.
Within archaeology, there are a range of commonly used data formats, but each excavation likes to use an adapted version of that. And that's why full quantification and open data is really important, because if you lay open everything you have, you also give people a possibility of criticizing the way you have described the data. I see a big potential of moving archaeology in general forward if we combine data sets. Then other excavators and researchers who do not even excavate would be able to take that data home and begin to compare and ask different questions than the excavators, for example, would have asked their material.
When you store and share your data in an open file format, or at least in a format commonly used in your field, you are improving the interoperability of your data, and it will help your colleagues, other researchers, machines, and your future self to reuse the data. The FAIR principles aim at maximizing the reuse of research data. However, it is very relevant to ask, can I make my data accessible for others? If yes, who will have access to my data and how? A case in point is research in personalized medicine that requires large amounts of personal data from many patients. But how can medical researchers collaborate and share data while still protecting the personal data of patients?
Our research focuses on trying to explain the underlying biological mechanisms for why some people, when they are undergoing chemotherapy, body radiation, transplantation, some people get sick from those interventions and others do not. And in order to address that question, we had to create a compilation of data that describes the course of what happens to patients over time. So that's essentially the creation of a data lake. And that data lake now encompasses around 180,000 patients, where we have their health data into one container, data container, in the last 30 to 40 years, depending on data sources. Of course, it is privileged data. Nobody wants to see their health data shared in the public for many extraordinary good reasons. And there is a lot of legality around getting access to data, therefore, that needs to be complied with for natural reasons. Other people can see in the data lake that the data are there on a metadata level, but not the content of the data, and therefore they can then seek a collaboration with those who have legitimate ownership of the data. So we have a governance structure that essentially allows for complete collegial thinking in terms of that, and where people who have a legitimate right over certain data, that they need to agree for the data to be used by others.
In your research, think about how you can make your data accessible and to whom. If there are no restrictions, the data can be made openly available to colleagues and collaborators, the broader research community, and the public. If there are restrictions due to, for example, intellectual property rights or data protection, you should still provide access to the metadata in order to comply with the FAIR principles. The metadata can include information on whether the data can be accessed, how to access them, or whom to contact to request access. So far, documentation, metadata, data formats, and access to data have been covered. If you want to make your data accessible and easy to find, you should assign a persistent identifier to your data. A persistent identifier is a long-lasting link to your dataset, just like the DOIs, Digital Object Identifiers, which are commonly used when referencing publications. This DOI will direct you to the journal website where the article is published. DOIs are also used as persistent identifiers for data. Adding a DOI to your data will allow you and others to cite them and give you credit for collecting them. But most importantly, others can easily find your data and access them if you can make your data openly available. When making your data openly available, you should always provide a usage license, which determines how your data may be used by others. The most popular data licenses are Creative Commons. With this suite of licenses, you can choose to share your data under more open or restrictive conditions. For example, if you select the Creative Commons Attribution License, CC BY, others may use your data for any purpose, as long as they give you credit the way you request. Or you can choose to restrict the use of your data, so others are not allowed to use your work for commercial purposes, and neither can they make any adaptations of your work. This is the Creative Commons Attribution Non-Commercial No Derivatives license. On a dataset, the license can appear like this. And here the authors have defined how the dataset should be cited. By now you have learned about different elements you must consider to make your data fair. Many of them are straightforward to implement in your daily work. Others might require special tools, for example those commonly provided by data repositories. Data repositories provide an easy way to publish data following the FAIR principles. They are a great way of reaching out to other researchers and the public and help you increase your impact as a researcher. Data repositories help to make your data findable, accessible, interoperable, and reusable by exposing their metadata on the internet and providing persistent identifiers and usage licenses. They can also provide a safe space for preserving valuable data for the future.
I think the potential for data repositories is maybe not to, say, replace journal articles, but to supplement and to add into that process. Historically, we've used relatively small amounts of data that could be represented in the charts and other things inside of a journal. But now, as we're getting larger and larger data sets, in order to have the full discovery that's important in science today, we need data repositories to make our data findable, to make it accessible, and also just to get credit for the sheer amount of data that we're working with. When you boil down a huge 4-dimensional data set to one 2-dimensional chart inside of a journal, it doesn't really give the feel for the importance of that data that we're producing and need in order to understand the phenomenon that we're looking at today.
Some research communities have a long tradition of publishing research data and have established domain-specific repositories, for example within geology and molecular biology. Some research institutions have their own repositories and can help you in publishing or archiving different kinds of data. Generic data repositories typically accept data independently of the research discipline and are used by researchers across the world. If you are in doubt about which data repository is most appropriate for your research data, the local data management support at your institution can help. To summarize, you make your data findable by adding metadata and a persistent identifier. To make your data accessible, you define who can access your data and how. Remember, if you can't publish your data openly, you should provide access to the metadata, for example through a data repository. To make your data interoperable, you use common standards and open data formats. And finally, you make your data reusable by adding documentation that help others understand your data and an appropriate data license that determines how your data can be reused. The FAIR principles allow for the broadest possible future use of your research data, by yourself, your colleagues and collaborators, by machines, and maybe even by the general public.